Hello everyone, welcome to yet another video series of measurement and instrumentation. In the last video, we have seen an introduction about measurement of resistances and impedance using bridges. So we have seen about what is a bridge circuit and what are the types of bridges and how the resistance are classified. We have discussed in the last classes. Now we will see what are the DC bridges, what is meant by a DC bridge and how it is used for measurement of resistance. So as far as bridges are concerned, it is classified based on the measurement of resistance and its value. If we are using a if you are using a bridges to measure a medium resistance, then certain methods will be followed. So the different methods used for measurement of medium resistance are ammeter voltmeter method, substitution method, and Wheatstone bridge method, which is the very efficient and commonly used method, and then is ohm meter method. If I want to measure an low resistance, then voltmeter ammeter method will be used, and an important method which is Kelvin's double bridge method will be used, and finally a potentiometer. If I want to measure high resistance, then direct deflection method can be used, loss of charge method can be used, and finally the mega ohm meter or Megger method will be used. So among all these three types of resistances, to measure each type of resistance, a bridge circuit is used. So first we will discuss the measurement of medium resistance using Wheatstone's bridge. A Wheatstone bridge is a type of DC bridge that is used for measurement of resistance which is unknown, and it is of the range 1 to 0.1 mega ohms. It is a series parallel combination of 4 resistance that provides zero deflections when the circuit is balanced. So it provides zero deflections when the circuit is balanced. The balance condition is zero difference voltage at the terminals of the null deflector. The principle of null indication is the basis of working of Wheatstone bridge, and thus it provides high accuracy in measurements. It consists of 4 resistances, out of which 2 are known resistances. One is a variable resistance that is used for balancing the bridge, or that variable resistance is the standard resistance, and another arm which consists of unknown resistance, and that unknown resistance value is what we need to find. Under balance condition, the ratio of the values of two known resistance become equivalent to the ratio of variable resistance and the unknown resistance value. Thus, it allows us to calculate the unknown value of the resistance employed in the electrical circuit. So, the circuit diagram shown in the presentation is the circuit diagram for Wheatstone bridge, a simple circuit diagram. Let us discuss about the construction of the circuit. The figure shows the general circuit of a Wheatstone bridge. It consists of 4 arms, namely AB, BC, CD and DA, each consisting of resistance P, Q and RS. Here R is the variable, S is the standard resistance and R is the unknown resistance. A galvanometer is placed at one arm which detects the flow of current through the circuit on providing the supply voltage at another arm of the circuit. So a galvanometer is placed at the unknown nodes of the circuit, that is between B and D. Now let us see how the unknown resistance can be calculated in balanced condition of a Wheatstone bridge. In the absence of any current through the galvanometer, the bridge gets balanced. In other words, the bridge gets balanced when the voltage difference between 2 points C, B and D are equal, thus providing zero voltage across the galvanometer. The sensitivity of Wheatstone Bridge is defined as the deflection in the galvanometer per unit. In the unbalanced condition of the bridge, when the current flows, it causes the pointer of the galvanometer to get deflected. Thus, the deflection rate is the function of sensitivity. A greater amount of deflection can be noticed for the same current in case of more sensitive galvanometer. The total deflection capital D is given by D into SI, where S is the sensitivity and I is the current in amps. So this is the formula for finding the unknown resistance. For the galvanometer current to be zero, the following conditions exist. I1 is equal to I3 is equal to E by P plus Q, because during balanced condition there will be zero current flowing through the galvanometer, hence I1 will be equal to I2. Similarly, I2 will be equal to I4. So by combining both the equations and simplifying it, we can find P by P plus Q is equal to R by R plus S, from which QR will be equal to PS. So we need the unknown resistance R, which is R is equal to S into P by Q. While measuring the resistance value, the Wheatstone bridge generally causes some error. The error in the standard arm R3 and the ratio R1 and R2 are very common. And galvanometer shows insensitive or insufficient null deflections when we go for measuring low resistances. Also, the resistance of the leads and contacts gets added when we measure low resistance. So in Wheatstone bridge, sometimes the measurement of low resistance generate erroneous results, and thus we are going for Kelvin's bridge in order to overcome this drawback. And also, due to heating effect, the standard resistance value gets altered. So it is always preferable to measure medium resistance with Wheatstone bridge, as for high measurement of resistance it is not suitable. This is so because in case of high resistance, the galvanometer is not sensitive to imbalance. Also, the heating effect due to the current in the circuit unnecessarily changes the resistance employed in it. This sometimes causes a permanent change in the resistance due to a large current in the circuit. Thus, from the above discussion, we can conclude that DC bridges that operate on DC supply allow us to determine the unknown resistance. However, an AC bridge allows us to measure resistance, inductance and capacitance when fed with an AC source. So with this we come to the end of this video. Whatever we discuss now are measurement of medium resistance using a Wheatstone bridge. So we have discussed about the limitations of Wheatstone's bridge as well. So to overcome these limitations, we are going to Kelvin's bridge to measure low resistance, which we will discuss in the next video. Thank you.